What kind of things did we look at, or what kind of problem? You guys don't remember? Talk about zombies? Zombies, right? And each zombie infected people a different way. So when you graphed it, remember on the left side is only goes from 0 to 100 days, or people, sorry. All right, and this one went from 0 to 1,000. So if you notice, this is much more zoomed in. It looks like the quadratic one, which is this green, is going up quickly, right? But look what happens as we zoom out. So as we zoom out, look what is happening to that quadratic. Is it going up as fast as we thought it was? No. But what goes up really quickly? Exponential. So anything that is exponential is always going to increase the fastest over a quadratic and definitely over linear. All right? So just remember, and that's what this was supposed to show you, is that exponential one increases really, really quickly, okay? All right, so this unit, we have been talking about 3 different things. What are the 3 different types of functions we've learned? Exponential, quadratic, and linear, right? So we are going to continue talking about function types, but we are going to kind of take a break from, a side step here, and we are going to review domain and range. So raise your hand if you remember those words, domain and range. Yes, okay. So today we're really going to practice identifying the domain and range from a graph. That's what we are going to focus on today. So since it should be review, hopefully, do you guys remember what the domain of a function is? What are you looking at when you look at the domain? Does anyone remember? The x values. You're looking at the x values or the x-axis. So that's why you want to look from left to right. Because left will be the smallest x value and to the right will be the largest, okay? All right, so what does that mean the range of a function is? Yep, domain is x, range is the y. So when I'm teaching kids about range, I say look for the lowest value, because that's going to be the smallest y value, right, to the highest value, because we always want to put them in order, all right? So when we list the domain and range, we are going to use a notation called interval notation. There are other ways to write it, but the most common way that's used is interval. All right, and when we're listing what the domain and the range is, when we include excuse me, I need a drink. When we include a value, okay, that means we are going to use a bracket. So we either use this left bracket or the right bracket. So if it includes a point, like if it touches or crosses a point on a graph, it's going to include it, which means it's going to have a bracket. When it's excluding it, okay, so it's excluding it, it means it's not going to touch or cross, or maybe on the graph, maybe there's an open circle on the graph, which I'm going to show you one in just a little bit. So if it excludes it, it's the parentheses. All right, so domain is the x values. We're going to look what to what? Left to right for the domain, and the range values we're going to look lowest to highest, okay? So let's look at an example. So here, this number 1, we have a line segment, okay? So with this line segment, it goes from here on the x-axis to there on the x-axis. So when I'm talking about the domain, I want to look from here to here. So, what's the smallest x value that this graph touches? Smallest x value? -4. Yep, -4. And then when I think about a bracket or parenthesis, I'm going to look at the graph. Well, is it touching -4? Yes, and that closed circle means it includes it. So if it includes it, that's going to be a bracket. Okay, so it starts at the smallest x value is -4. What's the greatest x value that it goes to, that it reaches? 5. So it's going to be -4, and you just do a comma to 5. And then it went to 5 on the x-axis to the right. So we went to the left was -4 is the smallest, to the right was 5 is the highest. And now I need to know, do I do a bracket on 5 or parenthesis? A bracket, because why? Because it includes it. Do you see how it has this dot and it's closed in? Okay, so that means it touches that point. All right. Have you guys seen this before? Yeah, from hopefully from last year, secondary math 1. Okay, now range. What are we going to look for the range? Yep, we're going to look at the lowest. I'm going to change colors here. Lowest y value to the highest y value. So we're just looking lowest to highest. So what's the lowest y value? 1, right? Because now we're looking at the y-axis. The lowest y value is 1. Does it include it? Does it touch 1 on the y-axis? Yes. So that's going to be a bracket. +1 to what's the highest y value that it goes to? 4. So 1 to 4. And it also includes that because it touches 4. So remember, domain, left to right, range, lowest to highest. Now, I also want to say something. If you put the range from 4 to 1, that's not correct because it needs to be in order. The interval notation always has to have the smallest number first, then the largest number. Okay, so don't put it out of order. Okay, let's look at number 2. Domain. Let me change my highlighter color. So I'm looking from left. Oh, what was that? I don't even know. Left to right. So I'm just looking across the x-axis. It's going, what's the smallest x value? -3. And does it include it? Is there a closed circle where it touches -3? Yep, so we put a bracket. And then 2, we just separate it with a comma. 2, what's the furthest to the right x value? 6. And does it touch 6 or include it? Yes, it does. So we put a bracket there. So -3 to 6. Now we're going to look at the range. So we're looking where first? Lowest to, and then I'm going to go to the highest y value. All right, sorry, Sean. Okay, so lowest y value is what? -6. And what am I going to put on -6? A parenthesis or bracket? Bracket. It includes -6. To the highest y value is this one up here, which is 7. And that, negative, I know, I can't ever leave it. -6, 7. Okay. Questions so far? I know we've only done 2 examples. We'll just keep cruising along. But as I'm going over them, if you have a question as to why it's anything, please just raise your hand and let me know. Okay, number 3, domain. So we're going to look furthest to the left. Well, what's happening with this function? Will it go forever to the left? Yes. So what's this? How can we represent the smallest numbers? Negative infinity. Negative infinity is not a number, it's an idea, right? The number's going forever. So since it can't ever equal infinity, we always do parenthesis negative infinity. So whenever you write infinity in your interval, everyone wake up, it's not nap time. If I'm not sleeping, you're not sleeping. Here we go. Sit up, sit up. Here we go. Okay, negative infinity, because it goes forever to the left, and then how far to the right does it go?
5.
To 6, right? So it goes forever to the left to 6, and does it include 6?
Yes.
Yes, right? It includes 6, so we're going to put a bracket. So remember, negative infinity means it's going forever to the left, right? It's getting smaller and smaller. Okay, and the highest x value is that 6. Now let's look at the range. Is this function going to keep going downwards? Yes, it's going very slowly downwards, but will it keep going down forever? Yes, so what does that mean? The smallest range value is negative infinity as well. Because it's just going to keep going. And what's the highest y value? So I look at the top. What's the highest y value? 2. And am I going to put a bracket on 2 or parenthesis? Bracket. Bracket on 2. Okay, questions on the first 3? Okay, I'm going to give you a head start on 4, 5, and 6. So I want you to write down what you, or at least on 4. Let's just do 4 for now. I'll give you a head start. Try something, even if you're wrong, that's okay. You should be writing this down. All right, what type of graph is number 4? Exponential, right? Has that curve? Is this going to keep going to the left? Is it going to keep getting wider to the left? Yes, very slowly, but it is. So the domain, it will go forever to the left, so we know it's going to be negative infinity. And always put a parenthesis on infinity, either one. And then will this curve keep going to the right? Yes. The x values will keep increasing. So the domain is everything, all real numbers, negative infinity to infinity. So there's no x values that are forbidden, okay? All right, now range. What do we know about an exponential curve? What do we know about this flat part right here? Is it ever going to touch or cross the x-axis? No, because this is, guys, my favorite word, asymptote. Do you guys remember that word? It's my favorite math word because it has a cuss word in it, but it's a math word. Asymptote, okay? This curve is going to approach this line but never ever touch or cross. Boys? So, if that's the case, my range is going to be, what's my lowest y value? 0. But is it ever going to touch 0? No. So we put a parenthesis on 0. And that says, hey, it's going to get really close to 0, but it's never going to equal 0. Right? Okay. And then will it go up forever? Okay. Deacon, you guys, knock it off. Whatever's going on, just stop. Okay, will it go up forever? The range, yes. So it'll be from 0 to infinity. Okay, and why did I put a parenthesis on 0 again? Somebody repeat. It's never going to touch 0. Because of what? What's my favorite math word? Asymptote. Okay, all right. Okay, I'm going to give you a head start on 5 and 6. Go. See if you can identify the domain and range on 5 and 6. What is number 5? What type of function is number 5? Really? The easiest one? Linear, right? It's a line. So looking left to right, is it going to go forever to the left and forever to the right? Yes, it will. So that means the domain, sorry, I forgot to put the domain on here. Negative infinity to infinity. I know, infinities, why are they like the hardest to write sometimes? Anyway, all right, range. Is this line going to go down forever? Is it going to keep going down?
Yes.
Yep, and it's going to keep going up.
Yes.
And there's no break in between.
Yes.
So range is also the same, negative infinity to infinity. Questions on the line? All right, what's 6? What's the name of this graph? Parabola. Good job. So parabola, let's look at the domain. So will this graph keep getting wider and wider?
Yes.
Yes, it will. So will it eventually go forever to the left and forever to the right if it keeps getting wider? Yes. So it's going to cover the entire x-axis. So the domain is negative infinity to infinity. Okay, now the range. Lowest y value. Well, is it going down forever? Yes. It only goes to what point on the y-axis?
5.
Only to 5. So we know it's going to go down forever, so it's negative infinity to the highest point is 5. Now, how do I know whether to put a bracket or parenthesis? Yes, if it touches that point, right, then it's a bracket. Now, however, if there's a graph that's a parabola but has an open circle right here, then it would be a parenthesis. If for some reason it had an open circle, not a closed. Okay. Now, do you guys have... Okay, I'm going to show you this example for just a second, okay? Because what's kind of the difference? So if I'm looking at the domain here, I need your eyes up here because it's going to help you on your practice, okay? So if I'm looking left to right, the furthest left is 1. Caleb, here we go. Furthest right is 6. But is something happening in between?
It's not the same line.
Yeah, so there's a gap right here, right? So I need to list the domain. Stop doing that with the can, please. I need to list the domain from 1 to 3 and from 4 to 6. Does everyone agree with me? Those are the x values.
Yes.
Goes from 1 to 3, 4 to 6. Okay, so when I write that, I'm going to write 1 to 3 with a bracket, 4 to 6 with a bracket. And when you have, okay, eyes up here. When you have multiple intervals, to kind of connect them, we use the union symbol. So it's a U. All right? So if you have a graph, because in a minute you are going to do some practice in just a second. If your graph has a break in it, then you're going to have one where there's a break in the interval. So you're going to have 2 different intervals maybe, okay? So any questions?